Welcome to the lecture series of Basic Electrical Engineering. The subject code is ECE 101. Today in this video we will discuss the topic step response of RC circuit. In the previous video we discussed the topic the step response of RL circuit. So in this video we are discussing the topic step response of RC circuit. In the RC circuit we are having the combination of resistance and inductance with a voltage source, and initial condition of the circuit is that this key switch is open. When the key switch is open, the circuit is at its initial state, means that the voltage just before switching on the circuit is 0, means V0 minus is equals to V0 plus is equals to V0, means at the initial stage we are having the voltage V0 in case of capacitor. Apply the KVL and KCL, apply the KCL at node 1, at node A. This is node A. In this circuit we are having two nodes, node A and node B. First we apply the KCL at this node. We are having the current IT. This is IT current. This is IT current and this is IR current. So one current is ingoing current and other current is outgoing current. So IT minus IR is equals to 0. This is the equation. IT is equals to IR. We are having one equation. Then apply the KCL at this node, node B. In this node we are having the current IR minus IC is equals to 0. So IR is equals to IC. So we are having two equations of currents at node A and at node B. Now apply the KVL on this circuit. When we apply the KVL, the equation will become minus Vs, the voltage across here, plus the voltage drop across the resistance VR, plus the voltage drop across the capacitor Vc is equals to 0. So this is the equation for the KVL. And voltage drop across the resistance VR is equals to RIR. Here as I have written RIR. IR in this equation, as we have written IR is equals to IC. So we replace IR with IC. It will become IR into IC. And we know that the current drop in the capacitor IC is equals to C dV by dt. So the equation can be written as minus Vs, this equation, minus Vs plus R, here I put the value of R, and IC, it will become R C dV by dt, that I put here, plus Vc is equals to 0. So after that Vc minus Vs is equals to minus R C d Vc upon dt. Assume that Vc is equals to this, Vc is equals to V. So we can write the equation V minus Vs, this Vc is equals to V. So V minus Vs is equals to minus RC dV upon dt. We can rewrite this equation, 1 upon minus 1 upon RC dt is equals to dV upon V minus Vs, this equation. Now take the integration of both the sides. It will become integration of 1 by minus 1 by RC dt from t0 to t is equals to integration dV upon V minus Vs from Vt0 to Vt. These are the initial and the final limits of the integration. When we solve this integration, it will become minus 1 upon RC t minus t0 is equals to natural log minus V minus Vs, the limits V t0 to Vt. So we rewrite this equation into this form. We open this natural log with the initial and final limit. The equation will become this. After that, we will get this final equation minus 1 upon RC into t minus t naught is equals to natural log V t minus Vs upon V t naught minus Vs. So take the antilog on the both side. The equation will become e raised to power minus 1 by RC into t minus t naught is equals to Vt minus Vs upon V t naught minus Vs. Here we are having the final time and here we are having the initial time. So rearrange this equation and this is our final response of the equation. Vt minus Vs is equals to Vt naught minus Vs into e raised to power minus RC into t minus t naught. RC is our tau and it is replaced, it can be replaced by tau. Now capacitor is fully charged when we are having the final condition, means steady state condition. The capacitor is fully charged. It acts as open circuit, as I have told you in the previous video. Recall that CSO means the capacitor at the initial condition is short circuit and at the final condition it is open circuit. When the capacitor is fully charged, it is open circuit. So here it is written capacitor is fully charged, it acts as a open circuit. So it does not allow current to flow, that is IR is equals to IC is equals to 0. So the equation will become minus Vs plus VR plus Vc is equals to 0. And when we put IR, VR is equals to IR into R, voltage drop across the resistance, IR is equals to 0. So this value is 0. So it will become Vs minus Vs plus Vc is equals to 0, or Vc is equals to Vs. We can say that here we show that voltage across the capacitor is equals to the supply voltage. Means when the capacitor is fully charged, the voltage shown by the capacitor is Vc is equals to Vs. So in equation 1, replace Vs by Vc. According to this equation, we will replace Vs by Vc. The equation can be rewritten as It is equals to Vc plus Vt0 minus Vc. Here we replace Vs with Vc. My e raised to power minus 1 by RC t minus t naught, and when we rearrange this equation, we will get this final equation. This is our final equation. Vt is equals to Vc bracket 1 minus e raised to power minus 1 upon RC t minus t naught plus Vt naught e raised to power minus R 1 upon RC. So complete response of the circuit is that forced response plus natural response. Here in this derivation we talked about the forced response because we show the external voltage source connected in the circuit, and natural response is that when we are not having the external source connecting to the circuit, as I have explained in the previous video. So the equation will become Vt is equals to Vc plus Vt minus Vc e raised to power minus 1 upon RC into t minus t naught. So replace this rc by tau. Tau is equals to rc, and we will get this equation. We replace this vc by infinity because this is our final value, means steady state value. So vt is equals to v infinity plus v0. V0 is the initial value. So we are having two conditions here. We are having voltage at initial condition plus the voltage at the final condition, and tau is replaced by r by c. So this is about the RC response of the circuit. In this video we talked about this RC network, where we are having the external voltage source, resistance and capacitor are connected in series with each other, and we prove the derivation, and finally we got this equation where we shown that Vt is equals to, this is our final equation which we use for solving the numericals. Vt is equals to v infinity plus v0 minus v infinity, and into e raised to power minus t by tau, and tau is equals to rc. So this is about your step response of RC circuit. Hope you understand this and you like this video. Thank you very much.